Good morning, everybody. Welcome to Friday morning, TGIF morning of Chem 1105 with your host, me, Dr. White. Good morning. It's Friday. It's a red Friday. By the way, this is my favorite color. If you haven't figured that out, see? See? Anyways, I just remembered I forgot to open up something, so you'll have to wait. All right, how come it didn't show up? Uh-oh, hang in there. I don't know why it's down here, but I'll fix it after class. All right, let's get going. Sorry for the delay. On Friday, a week from today, 11/12/21, I will be giving test number 3 online during our Zoom meeting, just like we did test number 1 and 2. You'll be downloading a password protected PDF file for test number 3 from the assignment area Blackboard, which will be available on Thursday, the 10th, or no, the 11th, 11/11/21, whatever that means. But anyways, on Friday around 10 o'clock, I will send out a password for the version of test number 3 that you should take. You'll have until 11:30 a.m. to finish test number 3 and upload your test number 3 answers to the assignment area Blackboard. It should take you about 40-45 minutes. How do I know that? Because I've given similar tests face-to-face, and their students get about 50-55 minutes, depending if I have a class right after my class that I have to get out of the room for. And for test number 3, if my memory serves me right, and thank God it is, all the students finish within 55 minutes. But it should take you about 40 minutes, but you're going to get a lot more because you have until 11:30 to upload it. That gives you plenty of time to scan it and upload it. That shouldn't take more than 15 minutes, but anyways, test number 3 will cover chapter 5, part 2, and chapter 6. And this is gases and solutions. Now, the test has 20 problems on 9 pages with 5 multiple choice, and some of the questions are multiple part, like part A, B, C, and D. And the points and the topic area, gases will be 48 points, solutions 57. And it adds up to a total of 105, which means, let me click on the right button, there's five bonus points. You pick which questions you want to call bonus points. I just make it add up to 105. Don't tell anybody I'm being nice. Shh. And on the next Wednesday, I will do my world famous review for the next test, in this case, test number 3. And by the way, have a great weekend. All right. Does anybody have any questions about test number 3 coming up a week from today? I'm looking at the chat. I got my speaker on. I'm looking there. Still looking at the chat. All right. Now, one thing I want to remind you, a week from this Monday, I'll be having my first cataract surgery on my left eye, which means we're not going to have class on a week from this, not this Monday, but a week from this Monday, but I will post a video. And as you know, I always cut the answers from tests when I go over it from the video, which means I'm not going to post the answers in a video. So normally the first class after I hand back test scores or post them and email out your individual points per answer email, I can't do that on Monday. So what I will do is the Tuesday, hopefully all goes well, that day I will go through the whole test number 3 with the correct answers, which I like that, special effects, awful. But anyways, I'll cut out of the video. All right, today I'd like to go through the chapter 5, part 2, solutions problem set. So I will. So let's do that. All right, now, chapter 5, part 2. I haven't asked this in a long while. Everybody see that on your screen now? Thumbs up, people. Thank you, Amber. All right. I give an example of by the way, you know why I call these practice problems, don't you? Hint, hint, wink, wink, say no more. That comes from Monty Python. I think it's wink, wink, hint, hint, say no more, but I modified it for Dr. White. All right. Give an example of colloidal dispersion that you use in your daily life. This is something you should know. Milk is an example, latex, and blood. And how do you know something's a colloidal dispersion? It will scatter light. If you take a light source and try and shine it through, hold on one second. I don't want to cheat you on a Friday. It's time for playing with flashlights with Dr. White. And if you have a colloidal, a regular solution where everything's dissolved and it's homogeneous, assuming there was water and sugar in there, there's not, but if there was, see how the light goes through? My red flashlight. Uh-oh, I hope I didn't blind anybody. But if this were milk or latex paint, like my hand, you wouldn't see anything through it. No, my hand is not a colloidal dispersion. Oh, that would be weird. But anyways, don't you love these red little flashlights? I do. I also have them in green. I gotta get a blue one. Anyways, you should know colloidal dispersion, because the particles are not dissolved, they're just dispersed, so they're floating around. Light comes through, it disperses it, it blocks it, what they call disperse. And that's something you should know. All right, give an example of a solution that you can use in your daily life. Well, one of my favorite is pop. And I think you already know my favorite pops are Dr. Pepper and Werner's. Now, you always forget about, at least students do, I don't, that air is a solution. So is gasoline. So is tea. There are many of them. Now, when we talk about solutions, there are two important terms you should know: solute and solvent. Solute of a solution, or solutes, are the components that are present in a smaller amount as compared to one component that's in the greatest amount. And the component that's in the greatest amount is called the solvent. So if I have 12 grams of potassium bromide, KBr, and 10 grams of water, I hope you all know that's H2O, which is the solvent, which is the solute? And the answer is, oh, surprise, it's not water. It's KBr is the solvent and water is the solute. And if I have 56 grams of ethanol and 125 grams of water, what is the solvent? What is the solute? And the solvent is, in this case, water, because it's present in the greatest amount. And ethanol is a solute. Oh, I think I'm going to have Share the Fun Friday. Ooh, that's the first time I ever said that. That sounds interesting. I just noticed I don't have my whiteboard open. So if you hold on, there we go. And here's one for you to try and have some fun with. If you have 30 grams water, 50 grams ethanol, and 500 grams of gasoline, then what is the solvent of this solution and what are the solutes? Your turn. And it's time to vote. Not everybody's voting today. I'll give you another 15 seconds. Still not everybody's voting today. Oh no. Remember, it's your civic duty to vote. Actually, it is. I have never missed a major election. I think years ago, I missed a city primary because I was traveling. I forgot to get an absentee ballot for a city. But any national or state election, I have never missed voting. All right, let's get going. What is the solvent of a solution? That's the component present in the greatest amount. And therefore, I hope you all know your numbers. And the solvent is gasoline because it's present in the greatest amount. And what are the solutes? All the other components, which in this case is water and ethanol. So remember, a solvent is the component present in the greatest amount. 500 grams is greater than 30 or 50. And all the other components are called the solute if there's only one, or solutes if there's more than one. Uh-oh, somebody should have told me you can't see the whiteboard. All right. I'm going to do another problem. Well, let's go through this again. By the way, sometimes, and I still do this, I forget to look at chat. Turn on your mic and say, I can't see the whiteboard, please. All right. Thumbs up, people. Can you see the whiteboard? Okay. Thank you, Mila. Thank you, Mackenzie. All right, let's go through this again, and I'm going to write another one. If you have 30 grams of water, 50 grams of ethanol, and 500 grams of gasoline, then what is the solvent of the solution? What are the solutes? And therefore, gasoline, which is present in the greatest amount, is the solvent, and the other components, water and ethanol, which are smaller amounts than 500, are the solutes. Hold on. Oh, excuse me. Slow developing sneeze there. And say 3 or 4 points. If you have 45 grams of oxygen, O2, and 10 grams of nitrogen gas, N2, and 7 grams of argon, which is a gas, in a solution, then what is the solvent and the solutes, I should guess say here, are the solvent and solutes for this solution. Your turn. And this time, I hope you can all see the whiteboard. Do I feel embarrassed? Not really. That happens on Zoom. And don't forget, If you want an instant replay later today, this and other lectures are available on my Chem 1105 YouTube channel. Don't forget, Dr. White's a YouTube star. Nah. All right, let's do this. We're trying to find what's the solvent, what are the solutes for this mixture or solution. And the solvent is the component present in the greatest amount, which 45 is greater than 10 and 7. So this solvent is oxygen, and the solutes are the other components, which in this case are nitrogen and argon. All right, let's get back to the problem set. And remember, if I'm thinking you can see a screen, you can't. Guess what? Turn on your mic and say something. All right, next we have problem 6. What is 1.34 capital M HCl mean? Well, let me remind you that you should look at important information, test number 3, which will be in the lecture section of Blackboard. And here, molarity, moles of solute per 1,000 milliliters. You don't have to put down the word solution. So if I go back, again, molarity, which I should really correct this, which is indicated by a capital M, is moles of solute per 1,000 milliliters of solution. So if I have 1.34 capital M molarity HCl, that means 1.34 moles of HCl per 1,000 milliliters. And let's have you try one. I'm going to share the fun mood, so I will. And here's one for you, and hopefully you're all seeing it. Let me do a double check, and you should be able to see that. Thumbs up, people. Can you see what does 7.811 times 10 to the squared capital M Na2SO4 mean? Do you see that? Thank you, Gabby. In case you forgot, remember, I'm cutting down the memorization, which helps you. In case you forgot, hint. All right, let's do this. What is 7.811 times 10 squared capital M Na2SO4 sodium sulfate mean? And the capital M is molarity. And molarity is moles of solute per 1,000 milliliters. Well, how many moles? Well, this number tells you. Then I'll have moles, and then I'll have the chemical structure, empirical formula. And this is per 1,000 milliliters. So that's what that means. Now let's move on. Ooh, number 7. What does 4.56 times 10 to the third capital M NaCl bracket AQ close bracket mean? And what is the solvent of the solution? Well, as soon as you see capital M, you know that's molarity. And that means there's 4.56 times 10 to the third moles of NaCl per 1,000 milliliters. Now, the AQ in the brackets means aqueous, which means water is the solvent. Whenever you see AQ after this, like I have, that's water is the solvent. And here's one for you. What does 1.11 capital N NaF sodium fluoride bracket AQ close bracket mean? And what is the solvent? Your turn. And the votes are rolling in. All right, let's get going. As soon as you see capital M, that's molarity. And in case you forgot what that means, molarity, capital M, and molarity is moles of solute per 1,000 milliliters of solution. Therefore, what does this mean? It means 1.11 moles sodium fluoride per 1,000 milliliters. And what's the solvent? Whenever you see AQ, that means the solvent is water. All right, let's move on. Now remember, and it'll be important information, molarity is moles solute per 1,000 milliliters of solution. And you should know how to use this. And I see a question. Okay. Anyways, let's go back to the problem set. Now that I've reviewed that, and now look at number 8. How many moles of sodium chloride, NaCl, remember, please pass the NaCl, remember NaCl's table salt, are in 125 milliliters of a 3.45 capital M NaCl solution. So when you look at this problem, what are you being asked to find? Moles of sodium chloride. What are you given? A volume of the solution. And this thing, 3.45 capital M NaCl. And therefore, if I look at this, I say, what does that mean? Well, capital M, molarity, what that really means is 3.45 moles of sodium chloride per 1,000 milliliters of solution. Well, the only real number we can start with is 125 milliliters. Now, let me move this out of the way. And what are we trying to get to? Moles of sodium chloride. And therefore, whatever I'm trying to get to goes on top of the ratio. Why? Because it's time to use your good buddy, your good friend, unit analysis. Bet you thought I wouldn't get this in today. Wrong, I did. And whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. Where do I get a relationship of moles of sodium chloride to milliliters? From the molarity. And I put in 3.45, 1,000. Now notice 125, 3 significant figures. Oh, he's in his rut again. Yep. Anyways, 3.45, 3 significant figures. The 1,000 is part of the definition. Therefore, that is an exact number. And milliliters divided by milliliters cancel out. And this is 3 exact number, 3 significant figures. And that's how you do it. And why don't you try this one on your own? If you don't have a calculator, first find out what are you being asked to find, what are you given, and then use your good buddy, your good friend, unit analysis to set up an equation. Speaking about calculators, if you still haven't mastered how to use your calculator with scientific notation, see me after class today or Monday night at my office hour. I'll be able to help because it will help you get more points on test number 3. You'll need a calculator. And when you're done setting this up and doing all that, give me a thumbs up. Oh, I was just thinking of something. Next Tuesday, I'm going to be trying something different in the lab we're going to be doing. No, I think a poll would work better. And for those of you who haven't seen it, they started, I think, a week or two ago. The Hallmark channels are playing, they're real sappy, but fun to watch Christmas movies again now. Boy, is it amazing? It's not even Thanksgiving. And even before Halloween, they're already pushing all the Christmas stuff. Boy, they really want you to buy. All right, let's do this one. What are we being asked to find? How many moles HCl? What are we given? 751 milliliters of solution. And this number, 1.761 capital M HCl. And as soon as I see capital M, I know that's molarity, which means this is really 1.761 capital M moles HCl, hydrochloric acid, per 1,000 milliliters. And therefore, this is the only number I have to start with, because this is missing some units until you do this. So I'm going to start with that. If I had a ratio, what would the units of my answer be if I multiplied that times 751 milliliters? Well, I want moles of HCl. And now I'm going to use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top the units. Whatever I'm trying to get rid of go underneath. So I'll write those in. And where do I get these numbers? Right here, because I knew what this meant. So there's 1.761 moles of HCl per 1,000 milliliters. Now, before I go and pick up my calculator, you'll see milliliters divided by milliliters cancel out. And now I'm going to pick up my calculator, turn it on, clear it. And my calculator gives me this number. And how many significant figures should the number have? The answer, I'll let you do. I'll give you 20 seconds. Go. That's about 20 seconds. This is 3 significant figures. Remember, every non-zero number are significant. This is 4 significant figures. This is an exact number. And if we look at that, what's the lowest number when you multiply or divide? Your answer should have the same number of significant figures as the number that has the fewest significant figures, 3. So I'm going to let you round this off to 3 significant figures. I'll give you 6 seconds. 2 times 3. Oh, I gave you more than 6. All right, keep the 1, keep the 3, keep the 2. That's my 3 significant figures. Use this to round off. It is 4 or less. I'll drop all this. And therefore 1.32, you can write it that way. Or if you want to put 10 to the 0, you can. Either way works, because 10 to the 0 equals the number 1. And that's how you do that. Remember, use your good buddy, your good friend unit analysis. Take the time to write down what are you being asked to find, what are you given. All right. Let me check. Everybody see problem 11 on your screen now? Give me a thumbs up. Uh-oh. Now do you see it? Thank you, Mackenzie. All right, let's do this. How many grams of NaCl, sodium chloride, are needed to make 345 milliliters of a 6.789 capital M NaCl solution? And this is real life. Now, there's no way I know how to go from milliliters to grams. I can't. I can go to moles, but not grams. And this is one where you need not one, but two steps. And if we go to important information, test number 3, molarity two-step problem. Step 1, milliliters to moles. Step 2, moles to grams. Hopefully I'll remember how to do step 2 from test number 2, because you're going to need it in test 3. In case you forgot, 1 mole of a compound equals the molecular weight of that compound, and the molecular weight of that compound is the sum of all atomic weights. So step 1, we want to go from milliliters to moles. Here are milliliters. We want to go to moles of sodium chloride. Use unit analysis. The moles go on top. Moles sodium chloride. The milliliters go underneath. Where do I get these numbers? From this number, molarity, capital M. Remember, moles of solute per 1,000 milliliters. And therefore, this is 6.789 moles of sodium chloride per 1,000 milliliters. Well, I put that in there, and I get this number. Milliliters divided by milliliters cancel out. I'm left with moles of sodium chloride. Now notice he's in his 3 significant figure run again. 3 significant, 4 exact number, 3 significant figures. Now this is a multi-step, in this case 2-step calculation. There are 2 ways of rounding off, at each step or at the very end. I'm an each step person. Now, I'm not going to force you to do it my way, so though I'll calculate both ways as correct answers for this test. Now, we have moles of sodium chloride. Are we done? No, we're trying to get the grams of sodium chloride. So step 2 is moles to grams. I have these many moles. I want to go to grams. I have this ratio, what goes on top using unit analysis, grams of sodium chloride, what goes underneath, moles of sodium chloride. You don't have to put the sodium chloride, you could have. And moles divided by moles cancel out. I'm left with grams. Where do we get this ratio? 1 mole of a compound equals its molecular weight, and the molecular weight of a compound in grams is the sum of all atomic weights. So for sodium chloride, down here, I have the molecular weight, 1 mole equals the molecular weight in grams, and 1 sodium is to 3 significant figures. Remember, look at the periodic table, the atomic weight is under the symbol, 23.0, chlorine is 35.5 to 3 significant figures. Remember on test 3, like on test 2, it will say under your name, please use proper significant figures for all calculated answers, and please use 3 significant figures for all atomic weights. So therefore, the molecular weight of sodium chloride, please pass the NACL, is 58.5. And so it's 58.5 per 1 mole, 2.34, 3 significant figures, 58.5, 3 significant figures. The 1 is an exact number. And here's my answer, 3 significant figures. If you notice, I have on there both ways, and I got the same answer if you round off at the end or at each step. And that's how you do it. I'd highly recommend you do this on your own. And I highly recommend you do this on your own, this type of problem. There are other examples I have here for you to work on. All right, I was thinking about what can I talk about that I haven't talked about that would be interesting to you today? Because first of all, are there any questions about solutions problem set? So, no question. I've got a couple minutes. So let's talk about acid rain. Now, you've learned from the acid-base chapter and hopefully you just saw what I drew. Let me check. And you did, you should. You should know this pH scale that I will not give you important information test for. And when the pH is below 7, it's acidic. So what is acid rain? It's rain and this won't be on test, but you should know it for your life. With something where the pH is less than 7. And in real life, a couple of decades ago, they were seeing in rain and also lakes pH a 2 pH, or better yet, pH 2, which is quite acidic. And guess what that was doing? That was killing off forests, killing off fish in rivers and ponds, doing a lot of environmental damage. Now, where did this acid rain come from? Well, it turns out that from power plants that burn coal and other things that they burn, like diesel fuel or gasoline or wood even, it emits certain pollution, sulfur dioxide, and nitrous oxides where X can be equal to 2 or 3. And if you have sulfur dioxide going up in the air, it mixes with the water and makes sulfuric acid. And you know that's an acid. And when it mixes with the water and it rains, you have acid rain. Same thing here. This is not a balanced chemical equation. So anyways, this forms nitric acid. And that mixes with the rain. Now, what the government did around 30 years ago is enacted legislation to lower the emissions from power plants, also from cars and chemical plants, but mostly power plants. And that caused the acid rain to be less of a serious problem. Now, one of the things when I was thinking about talking to you this day, I'm thinking, all the wildfires like in California and that, things that burn give off sulfur dioxide and nitric oxide, nitrous oxide, nitrogen trioxide. I wonder if that's going to affect and increase acid rain. Well, on that pleasant thought, we're done. I went a whole minute over. Sorry, bad Dr. White. With that, have a wonderful weekend. Don't forget to start doing your practice problems if you haven't for test number 3, which is a week from today. And with that, I'll say, I'm done. Gang gesund. Bye. I stole that from the Beverly Hillbillies granny. Bye now.